Hey guys, my name is Miss Wilson. This is a really odd angle for my face, but I think you're going to like it. So let's get started learning about physics. So I'm going to put my name up here at the top of my note sheet. You should do the same. Miss Wilson. And today we are going to be talking about acceleration. Now we've already started talking about acceleration. We've talked about vectors and scalars. We've talked about displacement and distance and speed and velocity and acceleration, but we're going to get a little bit deeper into acceleration today with some practice problems. So we know that acceleration is defined as a change in velocity over time. This is what acceleration is. And we know what velocity is. Velocity is a vector, so it has both speed and direction. So if acceleration is a change in velocity, that means acceleration can be both a change in speed or direction. One of my favorite physics teachers always used to say that acceleration is anything that causes the coffee to spill. If you're in your car and you have a mug of coffee and it doesn't have a lid on it, anything that you do in your car that's going to make your coffee spill, that's acceleration. So if you turn really, really fast, that's acceleration. If you speed up, that's acceleration. If you slow down, that's acceleration. So anything that causes your coffee to spill is acceleration. So we can do this like a lot of things in physics. We can describe acceleration with words, with graphs, and with equations. So right now we are going to use an equation to describe what acceleration is. Acceleration is a change in velocity over time. So it's going to be our final velocity minus our initial velocity divided by our change in time, where that delta here just means t final minus t initial. So you can write that out. T final minus t initial. So that's what acceleration is. It's just a change in velocity divided by a change in time. It's the rate of the change in velocity. So the standard units of acceleration, we can think about this really easily. If we have meters per second, that's the units of velocity, divided by seconds, the units of time, we get meters per second squared as our final units. I'll write that in words too. Meters per second squared. So those are our units that we'll always use for velocity. Whoa, crazy. So now let's go ahead and start trying to use this equation in some practice problems. I'm going to go ahead and circle this equation right here so we don't forget it, or right here. Okay, let's do some practice problems. So, a car traveling in the westward direction speeds up from 25 meters per second to 69 meters per second in 8 seconds. Calculate the acceleration. So the first thing we want to do is we want to find out what these variables are. So we know that this 25 meters per second, that's our initial speed. So we can go ahead and write the initial is 25 meters per second. This 69 meters per second is our final speed. V final is 69 meters per second. And then that 8 seconds is our change in time. So you can go ahead and write that out like that. Great, so now we have to calculate the acceleration. Well, we've been given all the tools we need to plug back into this equation up here. So we can just go ahead and put them in. So let's do that right now. We have acceleration equals v final minus v initial all over delta t. We can plug in those values. V final comes from right here, right there. That's 69. Our v initial comes from right here. Whoa, that was a crazy arrow. Let's try that again. Try that arrow again. Comes from right here. It's 25. And then our change in time is 8. And so that gives us, when we do our math on our calculators, which I don't have my calculator currently, and I'm not very good at quick arithmetic, so I'm going to just do it off to the side really fast. Divided by minus 25, that's 4. That's 4. Hopefully I'm doing that right. And if I divide that by 8, oh man, that's 5.5. Yeah? Is that what you guys are getting with your spiffy calculators? Don't be like me. Don't not have your calculators in front of you while you're doing your note sheets. That was a bad move on my part. Okay, so 5.5 meters per second squared. And we did it. That's our answer. Amazing. Okay, so now I want you guys to try to do the next one on your own, and we will come back in a second. So go ahead and do this number 2. Remember our equation. I'll leave it up for you. It's right here. So just take a quick second and do that next problem. Okay, so here's my work, which magically appeared for you here. So we have our initial velocity, our final velocity, and our change in time. We do final minus initial divided by time. And then, quick note, don't forget your sig figs. We go to 6.9 because there are 2 sig figs in 42, 2 sig figs in 66, and 2 sig figs in 3.5. So we go to 6.9, and don't forget your units there, your meters per second squared. Those are really important. So that's that problem, and then let's go ahead and look at the next one together. Okay. A bike traveling north slows down from 15 meters per second to 5 meters per second in 4 seconds. Okay, so this one's going to be a great time. I'm really excited about this one because there's some fun things to talk about. So here's our 16 meters per second. That is, it slows down, so its initial, the initial is 16 meters per second. Its final is this 5 meters per second, and this is our delta t. So given that, I want you guys to go ahead and also do this one, and let me know how it goes. I'll see you back in a few seconds. Okay, so welcome back, kids. So here our acceleration with the correct sig figs, don't forget your sig figs, is going to be -3 meters per second squared. So one thing to notice is this negative right here. Why is it negative? Well, remember guys that acceleration is a vector, and so it has both magnitude and direction. So that negative right there indicates the direction of the acceleration. Because this bike is slowing down, it's going to be a negative acceleration. So that's why we have that negative right there. So that's an important thing to remember, is that anytime you have something slowing down, or in other words, think about this for a second, speeding up backwards, you can think for a while about how slowing down and speeding up backwards are the same thing. But anytime you have something slowing down or speeding up backwards, you're going to have a negative acceleration. So those are our practice problems for today, and that's a quick tidbit on acceleration. Again, like I said, we will get more into acceleration, but that is your quick recap for today.